Okay, now let us look at example 14. A horizontal platform in the shape of a circular disc rotates freely in a horizontal plane about a frictionless vertical axle. The platform has mass 100 kg and radius 2 meter. A student whose mass is 60 kg walks slowly from the rim of the disc toward its center. If the angular speed of the system is 2 radian per second, when the student is at the rim, what is the angular speed when she reaches a point 0.5 meter from the center? Okay, so we are given diagram here. Di mana diagram ni, okay, dia tunjuk dekat sini. This is the student. So, student ni berada di atas platform. So, platform ni shape dia adalah circular disc. And then this platform will rotate slowly. Okay, like this. This is the direction of the rotation. Now, the platform has mass of 100 kg and radius 2 meter. So, from the center to here is 2 meter. And then, so the student here with mass 60 kg walks slowly from the rim towards the center of the platform. So initially dia dekat sini lah. It is at the rim and then they walk slowly towards the center. So apabila dia berada dekat point ni, the angular speed is 2 radian per second. Okay, angular speed of the student apabila dekat point ni adalah 2 radian per second. And then, we want to find what is the angular speed of the student when she reaches a point 0.5 meter from the center. So, apabila dia jalan slowly towards the center and then ada satu point dekat sini. Let's say lah, this one is point A, this one is point B. So, point ni adalah 0.5 meter daripada center. This one. So, apabila dia sampai dekat point ni, angular velocity dia sudah berubah, which kita kena carilah angular velocity dekat point ni. Okay, so let's list out the information. So now kita ada initially the student at the rim, so with angular velocity of 2 radian per second. And then this one at point A. This one point A. And then dekat point B, final, which is at R is equal to 0.5 meter. And then we want to find what is the angular velocity at this point here. Okay, first kita akan keluarkan formula untuk conservation of angular momentum, which is the sum of angular momentum initial equal to the sum of angular momentum final. Dan kita tahu angular momentum adalah sama dengan I omega. Okay, so initial dekat point ni, di mana kita akan ada angular momentum of the student and of the platform. So we have in moment of inertia of the student, initial angular momentum tambah dengan moment of inertia of the platform with the initial angular momentum. Okay, dekat sini angular momentum sebenarnya adalah sama. Okay, apabila dia berada dekat platform ni, dia akan rotate kan. So, student dan platform akan rotate dengan angular angular speed. Angular speed yang sama. So, kalau angular speed yang sama, kita boleh buat macam ni lah. IP initial, and then dekat point ni juga sama. Apabila dia berada dekat sini, platform dan student akan bergerak dengan angular speed yang sama. So, like this. Okay, so now this is what we want to find, the value for angular speed final. So, in order to find this angular speed final, kita kena cari dahulu moment of inertia, student and the platform. So untuk platform kita akan gunakan this value sebab dia adalah circular disc. Okay, so moment of inertia of the platform half mr square. So m is mass of the platform, which is what is the mass? 100. And then the radius is 2 meter. So you will get it is equal to 200 kg meter square. And then moment of inertia of the student at this point. Okay, dia akan berbeza at this point and at this point dia akan berbeza. Sebab the radius dia akan berbeza. So mr square. Untuk student kita gunakan di general equation untuk moment of inertia, which is mr square. So mass of the student adalah 60. Okay, radius dia initially dia berada dekat sini kan, dekat point ni, which is dekat hujung lah. So dia punya radius is 2 meter. And then you will get it is equal to 240 kg meter square. So this one adalah initial. So apabila dia berada dekat point ni, value R dia sudah berbeza. So the value for R is now 0.5 meter. So moment of inertia pun tidak akan sama lah. So we need to calculate that one. So we will get it is equal to 15 kg meter square. Okay, so now kita sudah dapat ketiga-tiganya. So just masukkanlah dekat dalam this equation. Okay, so now kita dapat the student initial 240, platform 200, and then initial angular speed 2, dan final 15 plus the platform 200. Platform dia tidak akan berubah. Okay, sebab platform ni dia punya radius fix 2 meter. And then angular speed final. Okay, so kita boleh selesaikan and then dapat the angular speed is equal to 4.09 radian per second.